learned about was the basics of calculus. I learned about different concepts like limits, derivatives, continuity, the squeeze theorem, and secant lines. Today I'll be talking about secant lines and what they are. When it came to calculating the slope of a linear line, like the one I'm going to draw right now, it was fairly simple. You just had to take 2 points on the graph of that linear line, and you just had to find the slope through formulas like y2 minus y1 divided by x2 minus x1, rise over run, or delta y over delta x. But things get a little more complicated when you go into graphs of different things like parabolas, curves, and other nonlinear functions like this one. So what we can do here in order to find the slope is that we can take 2 points. For instance, on this curve, we can take 2 points, and we can draw a straight line between them, like this right here. So essentially, that line is the secant line, and the secant line can help determine the slope of our curve. So by taking these 2 points, we can substitute into the slope formula, and we give the slope of our curve to some approximation level. So as we get closer and closer though, like this point and this point, if we were to draw a line between those, then we would get really close to the instantaneous rate of change in which our graph of a function is moving at. This is an example problem involving secant lines. A secant line intersects the curve y is equal to 2x squared plus 1 at 2 points with x coordinates 4 and 4 plus h, where h is not equal to 0. What is the slope of the secant line in terms of h? So the first thing we can do to solve this problem is by creating a graph, more of a table, of the x coordinates and the y coordinates. So we can write like x and y. So my table's x coordinates are going to be 4 and 4 plus h. So now all we gotta do is that we gotta substitute it into the original equation, 2x squared plus 1. So I'm just gonna write it right here, 2x squared plus 1. So 2 multiplied by 4 squared plus 1. 4 squared is 16, so we can just write, and 16 times 2 is 32. So 32 plus 1 is equal to 33. So we got ourselves a polynomial identity right here, which is a plus b the whole square. So what we can do is that we can do 2 multiplied by 4 squared, which is 16, plus 2ab, where a is 4 and b is h. So 2 times 4 times h is 8h, plus 8h, plus b squared, which is h squared, plus 1. Now we just got to use distributive property, and we got to basically multiply 2 by every single component inside the brackets. So we got 32 plus 16h plus 2h squared plus 1. And now we can add like terms, which would basically give us 2h squared plus 16h plus 33. So that is our y coordinate. 2h squared plus 16h plus 33. So now what we can do is that we can substitute these values into the slope formula of rise over run, which would give us 2h squared plus 16h plus 33 minus 33, the whole thing over 4 plus h minus 4. We can see that 33 minus 33 is equal to 0, so we can cancel those out. And 4 minus 4 is equal to 0. This leaves us with 2h squared plus 16h, the whole thing over h. do is that we can basically divide h by both these components to simplify. So 2h squared divided by h plus 16h divided by h. And this is essentially equal to 2h plus 16. And we got the slope of our line. So the slope of our secant line, the slope of our secant line is 2h plus 16.